Thank you, Vera. Good morning and good evening, ladies and gentlemen. My name is Wu Guolong. I'm the Deputy Director of Bureau of Standard Metrology Inspection, BSNI. As the Vera said, my director, Mr. Fang, has another duty. So I'm glad on behalf of BSNI to welcome you here today. In the new era of global pursuit of net zero transition, the number of business making net zero commitments is also on the rise as a new social contract for companies to face their responsibility in climate protection and resource use. A highly anticipated news report released at COP27 that outlines best practice for companies committed to net zero to provide guidance for corporates to prevent greenwash and deliver actual work in decarbonization. We also see the 24/7 carbon-free energy widely discussed in US and Europe. The 24/7 carbon-free energy compact response to the urgent needs to drive the rapid decarbonization of the global economy. Is composed of energy purchaser, energy supplier, governments, system operators, solution providers, investors, and other organizations by promoting 24/7 carbon-free energy to accelerate the grid decarbonization. In Taiwan, since 2017, the National Renewable Energy Certificate Center to coordinate and manage TREC insurance verification, promotion, and the related communication which cooperates. Until now, the TREC insurance has reached 2.9 million, which represents 2,900 megawatts hour of green electricity, supporting the strong growth of the voluntary market in Taiwan. One thing special in our TREC mechanism is that we incorporated the concept of time matching in our system by using smart meters to record power generation and consumption in 15 minutes intervals. The transfer power volume be calculated based on the time-matched power generation and the consumption, and then issue the corresponding TRECs. The power information is carefully tracked in the TREC system and disclosed on the platform for public review. In Taiwan, we were also discussing on the future of our green electricity market. 24/7 carbon-free energy is one of our directions. We are processing and to further support enterprises to achieve 24/7 use of renewable energy. Therefore, in the topics we highly concerned, we are honored to have all the experts to share their insights and expertise in this area. Today, we are honored to invite the Google, which aims to operate entirely on carbon-free energy at their data center and office worldwide. Energy Tech has launched to develop a standard for renewable energy user and to track the prevalence of their energy on an hourly basis. And the Energy Track and the Trace project started by ADR Group, which aims to allow all grid users to track the pace taken by renewable energy from sources to consumption. And the AIB will introduce how to reliable tracking of renewable hydrogens. Lastly, I would like to convey my appreciation to speakers for your time and support to this webinar, as well as TIER for organizing this event. Thank you very much for your participation and wish you all success with webinar. Thank you very much.
Well, I want to first start by thanking TIER for the opportunity to come speak today on Google's behalf on time-based energy attribute certificates and their role in our 24/7 carbon-free energy journey. As mentioned, my name is Hallie Kramer, and I am on Google's climate operations team. That team within Google is focused on our 24/7 carbon-free energy goal and also our net zero goal. So how do we achieve those goals and those targets by 2030? Within that team, I sit on a sub-team called the Data and Software Climate Solutions team. And we focus on what are those data and software requirements and needs that can help accelerate grid decarbonization, of which time-based energy attribute certificates play a large role and will be a big part of my presentation today. I'd like to start with some background and context on Google's energy journey. So as many of you know, we did not start with the 24/7 carbon-free energy goal. It's been an evolution as we've decided to get more ambitious in our targets and goals over time. And what I like about this graphic is it shows that that journey is not linear. It has different peaks and some valleys. It's not always a straight path, and the end of the climb is the hardest. So where we started with carbon neutrality, that used to be enough until we saw some issues of leakage and impermanence. Therefore, we moved to a more ambitious goal of 100% renewable energy. And when we achieved that, we realized companies could be 100% renewable energy and still rely heavily on fossil dependent grids. That's what motivated us to think about this 24/7 hourly matching goal, where when we have that hourly measurement and verification, we can then tell how much work is still left to be done to reach a true zero electricity emissions grid and emissions footprint for Google ourselves. The last thing I want to say about this journey is that it's not meant to be taken alone. As we are moving towards a 24/7 carbon-free energy future, we need to build a path for not only Google, but others, and we need to build solutions that can help accelerate progress towards that objective. When we talk about 24/7 carbon-free energy, you often hear the focus on the temporal aspect, the hourly matching aspect, but a big part of 24/7 is we need to think locally. We need to create opportunities for end consumers to act where they are consuming energy. I wanted to share this example from Taiwan as a local example of work that we wanted to do with local governments, with the local grid, to create opportunities to help decarbonize more quickly. So at the end of 2018, we signed a long-term agreement to purchase output of a 10 megawatt solar array in Taiwan, which will be located near our data center in Taiwan and connected to the same regional grid. This deal was made possible by discussions between Google, industry stakeholders, and the Taiwanese government, which amended the country's Electricity Act to allow non-utility companies to directly buy renewable energy and decrease their carbon footprints. And we are proud to be first corporate power purchaser to capitalize on that change to the law with this deal. And coming back to why we wanted to go a step further from 100% annual renewable energy and why that's not enough for where we were on our journey. When you look at this chart, you can see the black box is our example of a data center consumption, and you can see it's relatively flat. And the green spikes and the green profile is a carbon-free energy profile, mainly wind in this case. And even though in this chart, we are matching on an annual level the total volume between the green and the black, you can see that there are still gaps in our consumption profile where we have to rely on the grid, which might not be carbon-free. And there are times when we have excess carbon-free energy that exceeds our consumption at that time. So this move to a temporal match and a local match helps us focus on those gaps that we need to fill more closely. It's also important to think about the impact and why 24/7 carbon-free energy matters. An important piece of this is using data and research to inform what are the key benefits of 24/7 carbon-free energy. We are lucky to work with and to see research from leading organizations, including IEA, Technical Institute of Berlin, and Princeton. And I want to mention there's a new one from AirTrunk that just came out, so it didn't make it into this presentation, but it's worthy of a read as well. And they each look at what is the impact of a 24/7 carbon-free energy procurement strategy. What are the benefits? How does it compare to 100% renewable energy strategy? One thing I want to highlight here is that even with lower targets of 24/7 carbon-free energy, meaning you don't need to be at 100%, you can still surpass some of the benefits of RE100. And some of those benefits include emissions reductions that reduce reliance on fossil fuels. And you can stimulate earlier deployment in advanced clean energy technologies that are needed to firm the clean energy on the grid. And so being able to focus your strategy towards that is valuable in this case. It's also important to highlight that in this research, a lot of the benefits that we see are coming from that last 10 to 15% of 24/7 carbon-free energy. And you might wonder, well, why would that matter? Why would this strategy be pursued if RE penetration is so much lower than that today? Shouldn't we just be focusing on renewable energy? And I want to point out that it doesn't have to be an either or, it can be a both and. We need to do renewable energy and deploy that in large volumes, but we also need to think about what are those technologies, that flexibility that will be needed for that last 10 to 15%. By starting a 24/7 carbon-free energy journey, you can build a strategy that is future-proof. And even if you have an RE100 goal, so you're not yet targeting 24/7 carbon-free energy, you can still do hourly tracking and better understand what is the impact of your procurement on an hourly basis. The enabler of this is high-quality hourly data that can help you understand what's the best action as a consumer on the grid that can be taken today to help pursue those longer-term goals of grid decarbonization. Furthermore, by opening up this data and looking more granularly, there are new applications that we might not even be aware of today that could accelerate decarbonization and its impact. Last slide on the background of 24/7 carbon-free energy is to think more holistically about what is that strategy? What does it mean to move towards 24/7 carbon-free energy? So to achieve this, we'll need to do a couple of things. First, we need to advance new approaches for procuring clean energy, make sure there are options to participate, to procure, and to diversify the portfolio of clean energy that is available. Second, we want to drive progress in next generation technologies. This is both on the software side, where we can improve the economics and performance of existing renewables through advanced software and machine learning capabilities, but also on the hardware side. So how do we improve the next generation technologies that are needed, for example, through early pilots, where we can learn a lot before we need to move to a phase where we scale. And third, we want to work with partners to advocate for smart public policy. This can help us remove policy barriers. As we did with 100% renewable energy, we strive to move toward this goal in a way that creates opportunities for others so that we can maximize impact in accelerating the global energy transition. And although we're searching for that global impact, we realize that that needs to be founded in local action. Now, I'd like to move towards a better understanding of the role of time-based energy attribute certificates in 24/7 carbon-free energy. First, starting with how do time-based energy attribute certificates, also known as granular certificates or hourly energy attribute certificates, how do they enable 24/7 carbon-free energy? And the first way that they enable that is just by improving the granularity and the information that we have to monitor and verify our clean energy tracking. So these certificates are a form of crediting that can help us validate when we say we are 60% 24/7 carbon free. How do we prove that through the certification system? And how do we improve that transparency? The limitations of the system today are that we can't tell if the clean energy that is being produced is matched with our consumption. As shown in these charts, we see what is on the left, that block of clean energy, that volume at a monthly or annual level. And what we want to be able to see in the future is at that hourly level, what is actually being produced, where, and when. And TEEX can help us with that. Other benefits, and one of the core benefits of TEEX is that they can improve the transparency and accuracy of clean energy or green claims. This is really important in the days that we see today, where there are increasing concerns of greenwashing, for example, where we're losing trust in the carbon accounting claims that we hear from companies publicly. What moving to hourly can do, and what the accreditation of a TEEC can do, is that it can build that confidence in carbon accounting claims and also support better accuracy when you're doing it on an hourly basis. So when companies say they're at zero or they're running on 100% clean energy, that when you hear that, you would think there's no more work to be done, but they might still be consuming carbon on the grid. So how do we transform that messaging and use TEEX as the tool to provide the information that companies need to be transparent about their carbon footprint and also take higher impact actions? Next, I want to bring awareness to one of the major benefits of TEEX, which is that they can create a new value stream and market signals for clean energy when and where it is needed most. So last year, Princeton released a study that looked at a liquid TEEX exchange, specifically if there is a pool of buyers, energy buyers in a market that are procuring clean energy, but they might not have the same access. So you can imagine a company like Google might be able to go procure clean, firm energy. Another company might be able to procure power purchase agreements, but only wind and solar. Whereas a third company might not have the resources to do either of those and might just be procuring unbundled TEEX on an exchange. And when you have those differences in buyer preferences and abilities, the existence of a liquid TEEX exchange can improve the efficiency of being able to achieve a higher 24/7 carbon free energy target at lower costs. But through that exchange, you're also creating more effective price signals. As shown in this chart here, on the top, you'll see the price signals. On the bottom, you see a solar profile. This chart was taken from an example in California through this modeling. And you see there's an inverse relationship. So when solar is saturating the grid, when there's high solar penetration, the TEEC price in those solar hours is close to zero. On the flip side, when the sun is going down and the demand is ramping, that's when you see really high TEEC prices, where the value of clean energy is highest. So this is an example of a way that TEEX can create new value streams for that clean energy that is needed when and where. I also wanted to highlight the value of the pilots that we've done at Google. So at Google, we've worked with multiple partners, both on the registry side and on the software side, to better understand what does it look like to deploy TEEX solutions. And this can help us in making progress towards global TEEX adoption. It starts with piloting before we can scale and having lessons learned. One of the biggest ones being the pain points in data access that we often see. And that highlights a need for interoperability and standardization that can help us scale TEEX more efficiently in the future. That's one of the reasons why at Google we're so supportive of initiatives like Energy Tag, and Linux Foundation Energy is another one, where they are creating open source standards that can support this scaling of new solutions on a granular and hourly basis. We also look for opportunities to work with forward-thinking organizations like TIER in Taiwan to further develop learnings that can help make progress in this space. This slide highlights a immense amount of innovation that is happening across the TEEX ecosystem globally that is accelerating opportunities for clean energy. Now, the list here is not exhaustive, it's meant to be demonstrative, but wanted to show a sample of the types of companies along the value chain of a TEEC and the availability of new solutions that are being developed across all parts of this value chain, which demonstrates the increasing ambition to use granular data and transparent claims as a vehicle and a mechanism that can help accelerate decarbonization. Another enabler for an accelerated transition for TEEX adoption is policy. And I've included a couple of examples here on how that can help accelerate adoption. The first one is when we think about green hydrogen. And an example from Europe is they recently finalized the Delegated Act for Renewable Hydrogen, which will require that grid-connected hydrogen projects match their consumption with renewable electricity on an hourly basis EU-wide starting in 2030. And this is really important because it drives that demand for TEEX, and it's a signal to the market that this is needed to verify those claims and ensure that as we're growing and electrifying in the electric sector, we are doing that in a sustainable way with clean energy for these new applications of technology like green hydrogen. A similar discussion is happening in the US right now as it relates to a hydrogen tax credit, which is considering similar requirements. And TEEX are the natural solution for certifying that hourly matching under these regulations. Another example I wanted to highlight, this is out of the US as well, is the federal executive order to procure clean energy on a temporal and locally matched basis for 50% of the government's consumption. And they're doing this in order to catalyze the clean energy industry and jobs. So recognizing the need for a government signal to show that we need these clean energy solutions at all times of the day, not just variable renewable energy solutions. And we need to be thinking about that time matching to consumption on a local basis as well. The last thing I wanted to highlight as it relates to policy are that these system operators are supportive of TEEX solutions. So an example in Europe, and you'll hear from some of these folks later today, are that European system operators endorse the shift toward an hourly guarantee of origin system. They released a paper last year that argues that TEEX will reflect the real value of producing and consuming green electricity dynamically at each moment in time. And what this demonstrates is that we need to move to a system of thinking from the corporate procurement side that what we're doing really needs to reflect the physics and the reality of the systems that we're operating on. Another example from Thailand, the Electricity Generating Authority, which is promoting a 24/7 renewable project showcasing a hybrid solar battery solution. Lastly, I want to say that though there has been very good progress in these areas, there is more to do. Continued support is needed to help us scale these solutions and move towards a decarbonized grid. First, we need to continue to demonstrate the demand for this granular matching and request TEEX for purchase clean energy to help validate a 24/7 strategy and objective. And this demonstration of demand can incentivize and have a feedback effect with registries and utilities to supply this data, this information, and this certification moving forward. Second, we need to support the promotion of TEECs as part of natural design improvements in corporate clean energy markets that better align the energy attribute certificate markets with electricity markets. So this relates back to what I was saying about how do we better reflect in a systems thinking world, what are the needs of the grid to maintain reliability, to ensure that we decarbonize as we electrify, and all of those good things. And third, it's increasingly important that organizations are prepared for digital transformations and continued data-informed decision-making. So digitalization, bolstered by open source solutions, can enable a more resilient, transparent energy system and faster innovation while reducing costs and increasing flexibility. What I will leave you with is that at Google, we see TEECs as a foundational building block to develop the solutions that are needed for a clean energy future. And that is all I have for you today. So again, thank you for having me, and we can open it up to any questions.
Good morning in Taiwan at this moment. And I'm Yan Hao. I'm very happy to have an opportunity to talk about how to use the T-REC to support a company to achieve 24/7 carbon-free energy. I think previously Hallie has shared the point of view of from enterprise, why enterprise trying to achieve the 24/7 for the future. And I think in my presentation, I think in Taiwan, we have very good opportunity because T-REC fundamentally is a so-called time-based energy attribute certificate tracking system. And of course, I think most of the people here have already the experience of joining the corporate PPA market or renewable energy market in Taiwan. And we still have a lot of challenge. So probably how to achieve those more aggressive target, maybe I-100, and how to keep the liquidity of the market, as Hallie talked about, should be taken into consideration. And firstly, I'd like to show the introduction about the TIER. And TIER is the government think tank, the first private independent think tank in Taiwan, be founded by Dr. Gu Zhengfu, and in 1976. And our team support BSMI to working on the Taiwan Renewable Energy Certificate mechanism since 2017. And our team, because at that very early moment, there's no one really knows how to corporate PPA to be working in Taiwan. So we also doing some consultancy service at that moment. And until today, we have support more than 40 companies to get involved in the renewable energy market in Taiwan. And we're still trying to help more company or different kinds of company, for example, the small, medium-sized company to join the renewable energy market in Taiwan. But of course, we also looking at observe the international trend of the development of renewable energy market for the future. Next slide, please. And firstly, please allow me to introduce about the T-REC developer situation at this moment. And why there's more and more enterprise in Taiwan trying to sourcing renewable energy in Taiwan. I think there are several factors to driven this trend for enterprise in Taiwan for looking for new clean energy. I think, of course, most of them are trying to demonstrate their climate leadership to the market to have better reputation. But of course, we know that most of the enterprise in Taiwan, we are so-called invisible champion. I think that is a term in Taiwan. That means all our enterprise have very good performers to support international supply chain. And as we know, and of course, we also know that recently there are more and more carbon border adjustment mechanism happening in the world. And also, our president had announced a 2050 carbon-free target for Taiwan. So we see that based on those supply chain requirements, or the green trade compliance and the sustainability commitment, and also more and more domestic regulation, all that's kind of factor driven our enterprise to pursuing the net zero. Of course, as we know that in Taiwan, most of our manufacturing enterprise, their emission is the majority of their emission is Scope 2 emission, and that's why using a renewable energy is very important for them to use a so-called market-based tool to reduce their carbon emission of the Scope 2. And so that in 2017, the government has decided to develop a TREC system, Taiwan Renewable Energy Certificate. This system is very important to support the sustainability transaction of the renewable energy electricity, because based on the TREC mechanism, the end user could distinguish where their electricity come from. So that government has decided to have a TREC mechanism, play the role as the, we can call it as the identity for each kilowatt hour, for us to really know where our electricity come from and how they will impact the environment. And of course, this TREC system could also support the enterprise to their carbon inventory process using the market base. And also it is also important for enterprise to use those TREC to claim where the electricity come from. And until today, TREC has issued several types of renewable, such as wind, solar, biomass, and small hydro. Next slide, please. And here is, as we know, that BSMI is the government agents in charge of the TREC mechanism, and also the issuer of the TREC, Taiwan Renewable Energy Certificate. And the Taiwan Renewable Energy Certificate Center played a role of implement the whole mechanism. They help the enterprise to issue, transfer, and do the claim management of the TREC. Of course, they also doing the data analysis, OD process, or tracking for the whole TREC system for each kilowatt hour from the generation side to the end user part. Next slide, please. And I think most of the audience here know he's a TREC transfer model in Taiwan. Majority of the renewable energy, of course, go to the feed-in tariff before the market is open. And until today, after we have amendment of our Electricity Act, now we have opened the renewable energy market. That means that if the electricity is from the renewable energy generator, and that kind of electricity could be traded freely, and the Taiwan Power Company will help the enterprise to do the wheeling process of the renewable electricity. Of course, if you are for the small medium enterprise, they might don't have the time or have the capability to negotiate directly with the generation part, so that we have the renewable energy retailer to help them, to help the end user to negotiate with the renewable energy generator. And then the other possibility to sourcing renewable in Taiwan is, of course, you could use the self-generation and consumption pathway like the 4A. And we still allowed several unbundled REC for the charity process and the 4B process. As we know, many financial holding company, they're using the pathway 4B to doing the charity process. For example, they're using the REC generated by those self-generation generator, using for claim they're using renewable, and the power is delivered to the and to the enabler houses or institute, caring institute. Next slide, please. And here is the issue of the T-REC. Recently, as we know that the demand of the T-REC from the market is very strong. And until today, there is already 2.8 million T-REC has been issued. And I think we are very, and also thanks for all the people or enterprise, all the generator or the retailer, staff, people. This is what we have achieved, because and until today, 99% of the T-REC is bundled, only 1% is unbundled. I think several friends from told me this is a good example of so-called anti-greenwash REC tracking system, REC mechanism or market. Next slide, please. And I think this is the demonstration of how power is being delivered from the generation side to the end user, and through the power grid service provided by the Taiwan Power Company. And I think based on those willing process in Taiwan, you can source renewable from different places in the same power grid. And also we'll say that we thanks that Taiwan Power Company provide that kind of service, so that all the renewable energy transfer has so-called the physical links between the generation side and the consumption side. Next slide, please. And then I would like to share why and how our T-REC system is so-called, I think Haley has talked several times, so-called a time-based energy attribute certificate. I think this is thanks to the Taiwan Power Company again, because or the government, because I think from maybe 10 years ago in Taiwan, we talked about AMI smart meter infrastructure. And so the government has the policy to implement the AMI system from high voltage customer. And until today, for the AMI for low voltage customer implementation is still ongoing every day. And the AMI system also combined with the T-RECs. Next slide, please. And here we see that this is how the T-REC work together with the AMI system. The issue of the T-REC is very special, because in Taiwan we have the AMI system to record the electricity generation or consumption in 15 minutes interval, and the issue and the transfer of the number of T-REC is based on those AMI record message, so-called time match generation and consumption. I think that please come back to the slide. Thank you. And I think from the slide in the middle of the graphic, you see that this the green curve is a traditional wind generation curve, because usually the wind is being generated during the nighttime in Taiwan, and usually in the daytime the generation of the wind farm is less strong, the wind less strong, and the generation less power. And if if an end user is the original power, the curve is the consumption power, and we can see there's some mismatch between the green power generation and the power consumption in specific corporate PPA. And based on the Taiwan Power Company fulfilling a rule, that means if there's a surplus of the renewable energy generation compared with the end user consumption, Taiwan Power Company, the public retailer, will play the role as the off-taker of those power with the feed-in tariff. And if at a specific moment the end user consumption more power than the renewable generation asset, the power generation generated by those renewable energy power asset, of course, the Taiwan Power Company, the public retailer, will play the role like a load serving entity to provide the shortage power to the end user, so that the end user can always balance their power consumption and generation. But of course, that also means, as Haley say, that the end user at that moment, they're using the not a carbon-free electricity, they use the general power from Taiwan Power Company. And so that, of course, we say that the TREC system now is a so-called time-based energy attribute certificate. So of course we can make sure that the generation and consumption is highly matched with each other. But the challenge for our system at this moment is, if you only source one, if you only use corporate PPA, of course you can source in different kinds of renewable, and it's still very difficult to achieve 100% renewable energy consumption 24/7 in Taiwan. Next slide, please. And here is what we see so-called in an hourly based diagram. As we see that the whole power system, the deep color blue curve, and the generation part is the bar. We can see that because we try to keep the balancing or keep the frequency stabilize the balancing. Of course, the whole power system generation consumption is balancing each moment. And the lower part of this graphic, you see that the total renewable energy free trade renewable generation, the generation curve is the green curve in the middle, and the consumption of those end user who has signed a corporate PPA, the consumption probably will be the light blue curve in the middle. And of course, the Taiwan Power Company try to stabilize the power system. The power system, the generation consumption is balanced, but the whole renewable energy market power generation and the whole free trade market consumption curve is not balanced. Actually, we can say that Taiwan Power Company help all the corporate PPA to do the balance for those the free trade generation and the whole free trade consumption. Next slide, please. And here is, as we know that in Taiwan, if you really try to reach 100% renewable, it's very challenging. I know there are several companies in Taiwan who really try to achieve high renewable energy procurement ratio or high renewable energy consumption ratio, and they use all kinds of analysis and to try to sourcing all kinds of resources of renewable to reach that portfolio, but still very challenged, because we know that even during the winter time we have strong wind, but during the summertime recently the wind, the performance of the wind generation might be not so not so good. And of course, in the summertime, more hydropower can compensate those insufficient part of the wind generation power generation. But I think most of people has involved in the Taiwan renewable energy market know that now it's very difficult to find more hydropower for them to source renewable. So so that if you want to really reach a high percentage of the renewable consumption percentage, I'll say it's cost more, and it's also very challenging. Next slide, please. And from the other part of the Taiwan Power Company, who really responds for balance of the power system, we can predict that if our renewable energy market continues to grow, because I think we all see that recently the free trade power market in Taiwan grows really fast, almost double every year. And based on that trend develop, we think that the operation of the whole power system will be very challenged and very difficult for Taiwan Power Company. In this diagram, this is an extreme case based on our imagination that if we still develop those or sourcing renewable, and we don't really take the balance of the renewable energy, we sourcing and our consumption in the renewable energy market in several specific time interval, it will be a great challenge for Taiwan Power Company, because they cannot use their resources to balance the power grid in the future. You can see maybe in the middle, there's several red part. That means even in those high renewable generation time interval, the Taiwan Power Company should stop all their generation asset to generate power in specific hour, and after that, they should turn on or run up all those generation asset again. Actually, for the traditional power generator, it cannot be operated in that way. So that we can imagine if there is more renewable energy be developed, and we do not really consider their generation character in different time, and we cannot increase the more renewable energy penetration rate in the whole power system. And that also means it will limit the development of the renewable energy market in the future. Next slide, please. So here is some point we see, or we can expect that. I think now the offshore wind farm development in Taiwan is going on every day, and more offshore wind farm is also be developed. And most of those offshore wind farm also based on the corporate PPA as their cash flow source, so that we can expect that in the future the free trade renewable energy market growth will continue to grow very fast, and maybe double in the future, because more renewable, even the offshore wind farm will be connected to the power system. And if with the off-taker sourcing renewable, and they don't really take those time matching of the generation and the consumption, I think the free trade, the renewable energy market will be very difficult to develop. And that also mean the power system operator they need to invest more balancing resources to stabilize the power grid. And all that kind of cost, of course, will be should be taken by someone else. That also means the free trade renewable energy market growth of renewable energy market will become another additional cost for the whole power system operation. And so that we think that the renewable market should have a self-balancing mechanism, so that to keep the power system generation in a more balanced way, and to avoid the grid operator should do more investment for those by the system operator to balance those resources. So I think then we find there's something we need to face for our renewable energy market, that how to ensure the free trade renewable energy market and can really take into consideration about the balancing of the generation and the consumption in the whole corporate PPA perspective or hold a market perspective. That will be very important to support the growth of our renewable energy market for the future. Next slide, please. So here is the idea. We're trying to propose how to really using the so-called time matching issuing model of T-REC currently to support the enterprise to really reach a 24/7 target. If there's enterprise who really want to demonstrate their power is 24/7 carbon free. Next slide, please. We can what if we want to achieve that target? What should be take into consideration? The first thing, the foundation is the sustainability verification of commodity transaction management. I think it's very important that the we use in Taiwan in T-REC, we use so-called power flow balancing based on the AMI system. This could prevent the greenwashing of the when the end user claim they sourcing renewable. I think we already have that good foundation, and the challenge from our side is how to really help the so-called end user who's sourcing their electricity based on hourly base and to reach 24/7 carbon-free electricity. And another challenge is that at that moment, we also can support the power grid stabilizing. And so we need a new mechanism to overcome those two challenges. Next slide, please. And we think that renewable energy power market is very important and the key factor to achieve overcome the two challenges we have mentioned previously. And we can see what is the current. We can see in the graphic that we can see the graphic. I think currently all the individual corporate PPA, the Taiwan Power Company use their resources to help individual corporate PPA to do the balancing of 15 minutes interval to absorb or supply the power from the renewable energy market. And this is also why in Taiwan it's very difficult to really reach 100% renewable, and because we still do the balancing using the general power from Taiwan Power Company. And so if we can have a power market who can who can help individual renewable energy corporate PPA to do the 15-hour balancing between their generation and the consumption. Then of course, use that kind of market can support the individual corporate PPA to reach 24/7 renewable, and in the market we can see the market could driven the investment of the renewable resources in renewable shortage time interval, or maybe the green hydrogen the project could be developed to supply renewable power in specific time interval, and if the market price is in specific hour, the renewable energy price is high, then the market could using even a battery to shift renewable energy to those high tariff renewable energy tariff interval to support the market to help the renewable energy individual corporate to sourcing renewable in individual even hourly basis. Next slide, please. So here is some imagination of how the system, the market work. Currently in our renewable energy market in Taiwan, I think based on our experience, we always sourcing renewable from so-called capacity market. That means we sourcing renewable based on capacity, the number of the capacity of the generation, and of course, if, for example, if we sourcing 10 megawatt photovoltaic, we can expect that our power during the daytime we can source in renewable because the photovoltaic is generated during the daytime, but during the nighttime and it's difficult to to claim to source in renewable because all the asset we sign a contract, they don't generate the power during the nighttime. But if we can have a so-called renewable energy power market, then we can source in renewable in the rest of the time. Maybe in the nighttime, we can sourcing renewable energy power through the market, then can help the enterprise to really reach 24/7 carbon-free electricity. And of course, we also can imagine if we sign the corporate PPA, we sign a corporate PPA in specific time moment, and the asset generate more power as the energy consumption from the end user. They can also those surplus power could be traded through the renewable energy power market to the other end user or the other corporate PPA for them to source in renewable, so that we can also improve maybe previous Hattie has said the liquidity of all the renewable electricity in the future. Next slide, please. And here is some idea how the system work. And based on our imagination, we think that that could be, or it will be easier for the market to run in the so-called day after market. We also can think that this market is a day after settlement process. That means in the day one, we already know the 15 minutes matching between the power generation and consumption, and there's if there are surplus power, maybe they can sell those power through them in the market based on hourly each hour commodity. And if there's some end user in specific time interval, they they don't have renewable energy, then they can try to source renewable at that specific moment through the market. And after the transaction, the Taiwan Power Company to help those company to the second round of wheeling power calculation based on the transaction result, and also at the end, if there's still some power cannot be taken by the end user, of course it can still go to the feed-in tariff. And if there's some end user they sourcing renewable from corporate PPA, or they still some moment they cannot find any renewable energy power from the power market, then still the balance will be taken by the balance will be supported by the public retailer. Next slide, please. And that is the concept we are thinking could really support the develop of our energy market for Taiwan for the future. We can expect if the market has really the day after market has been created for the end user or generation to do the balance. After that, we will really have the so-called time value of renewable energy. Then we can attract the investment of the battery, or the investment of maybe green hydrogen based on the time value of renewable electricity, and the track record of the whole the renewable energy power market would support the project to be calculated and to be implemented, so that we think the renewable energy power market will be a key factor for us to continue to grow our renewable energy market, and also to support our power grid can really decarbonize for the future. Yes, sir. And we are trying to have that kind of project, so that I think in Taiwan we already have a national value of the so-called time-based energy attribute certificate. And what we need to do is, if we can really have that renewable energy power market, and it's very possible we can really support our enterprise to reach 24/7 to or help them to really or easier reach IE100 target under the bundle way. Exactly. And at the end, I'd like to share with you that the renewable energy market in Taiwan continues to grow every day very fast, and we can expect that for the future. And we know that we have already the green leasing program in Taiwan, and now more building already apply those mechanism. We can expect next year there will be more than 30 or 40 building to using the green leasing process to encourage the renter to using renewable electricity. And we also can expect that more so-called maybe iron generation process also will sourcing renewable, because maybe some fastener they want to using lower carbon iron material to reduce their embedded emission, and also in the transport sector now also a lot of electric vehicle end user now talking about using renewable and the green hydrogen in Taiwan. If we can have a 24/7 mechanism, I think we can also have the green hydrogen can have the fulfill the requirement as the and have the confirmation of the green hydrogen standards. Next slide, please. Yeah, I think that is what we're trying to share with the whole audience today. And all the renewable energy power market mechanism probably will be have a pilot project run in the very near time. If you have any interest in about to work together with the pilot project, I think you can try to contact us, and we can talk about how to really help Taiwan renewable energy market to have the mechanism to support enterprise to really reach I100 and also 24/7 carbon free in the future. Thank you.
And we'll get going. So the idea is I'll run through a quick presentation of why I think this topic is very important, and a little bit about what Energy Tag is doing to help make it happen. I know we have some great speakers coming up also after me who'll be providing also more detail on their implementation and their views on this topic. So first of all, what's Energy Tag? So we're a non-profit based in London. I personally live in Brussels, so we're very focused on Europe, but also internationally, working a lot with partners in the United States and in Asia Pacific region to do essentially three things. So to develop standards for granular certificates. So we have the Granular Certificate Scheme standard, which is being implemented now around the world and supported by over 100 organizations. So it's the only international standard for hourly tracking or 24/7 tracking of electricity. We also coordinate a series of pilots and demo projects for granular certificates. I know that the tier system is one of those. The Taiwanese system is one of those. There's 12 of them at the moment. We're a couple of terawatt hours of tracking done. And then finally, also, we work on a number of policy topics. Obviously, as now we have new instruments, next generation of electricity tracking, that has implications in policy. So, for example, and in particular around the production of hydrogen, we have to do more granular tracking than annual tracking, just to be sure that we're really producing truly green hydrogen every hour and not calling on fossil fuels in certain hours. So we've worked a lot in the European Union on their regulation for hydrogen, and now working heavily also in the United States, who are putting together their set of tax credits under the Inflation Reduction Act for clean hydrogen, again, where hourly tracking is needed. And a major global topic for us is the Greenhouse Gas Protocol, which is, of course, the voluntary standard for carbon accounting for corporates, which is under review also right now. So that's a little bit of an idea of our community. We work with some very large consumers, with some tracking companies. There's obviously a number of suppliers and market operators who are also interested in Energy Tag, and we interact regularly with various governments and other NGOs also. So just a bit of a step back about why this matters. So half of the world's electricity is consumed by the commercial and industrial sector, 60%, I think. So if we're not leveraging that demand properly, we're going to severely struggle to decarbonize the electricity sector and our grids in general. So we need mechanisms that send very accurate price signals for the decarbonizations of our grid. The best, at least in our view, the most robust and advanced type of procurement that one can do is around granular certification, is implemented through granular certification, and basically ensures that the consumer is getting carbon-free electricity in the same hour, on the same grid, and ideally from new assets, so that they're driving new demand for clean energy and new supply of clean energy. And these are very much in line with the principles of the United Nations 24/7 Energy Compact, of which Energy Tag is a member, and contributes to regularly in terms of their workshops and webinars. So that's the 3-pillar approach for best-in-class procurement. Why is granular emissions tracking important? Why bother doing all this complicated granular tracking? Why not just keep it as it is? This is a good example from Peninsula Clean Energy in California, which shows 100% annual renewable profile up here at the top. And basically what happens is you take certificates from the green times when it's sunny, and you use credits to offset the hours, like in the middle of the night when there's very low amounts of renewable energy. So that's really not sending the right signal. It's really not getting us where we need to go. We need to move towards granular tracking. So at the bottom here, you have a profile that's 99% matched with clean energy on an hourly basis. And there we see much less high intensity electricity in reality, right? So we're seeing actually the likes of storage, geothermal energy in California being used to fill in the gaps, fill in those hours, like in the middle of the night when you know, typical wind and solar is not available. So essentially we're moving towards a system here where zero really means zero. Also, in terms of decarbonization, this is a graph from McKinsey showing different types of PPAs and their emissions impacts under different accounting frameworks. So 100% renewable PPA just with solar energy on an annual basis. So you're basically, again, taking hours where you're overproducing and using them to offset your nighttime consumption. In reality, it only gets you about 50% max of emissions reduction potential. So that's good, but it's not the end of the job. Wind gets you further, but obviously a 24/7 clean PPA really drives you down to 100% real emissions reduction, and that's ultimately where we need to get to. It's very good to get started and to do annual matching for wind and solar, but we also need to think about storage, we need to think about flexibility, and that's what 24/7 PPAs actually do. This is a very striking example. This is a piece of research done by Princeton University, basically showing the carbon intensity of green hydrogen, or what we would call clean hydrogen or green hydrogen, depending on the type of procurement or accounting framework that is used, okay? If we use annual matching in the United States, essentially we end up with clean hydrogen that is more emissions intensive than grey hydrogen, okay? So it's actually worse to produce hydrogen using fossil-based electricity than just simply using that fossil fuel or natural gas in a standard steam methane reformer for grey hydrogen. So it's really important that, you know, companies or countries looking to implement large amounts of green hydrogen use 24/7 or granular accounting, because hourly matching, as we show here, is the only way that you can actually be sure of using grid electricity that actually you know, is matched on an hourly basis with clean energy, and hence leaves you with low emissions hydrogen. Any other methodology, even if it's weekly matching, even if it's daily matching, does not work, and will leave you with grey hydrogen, with clean hydrogen that's actually taking you a step backwards. So you might end up subsidizing, spending a lot of taxpayers' money on a hydrogen sector that actually starts to emit more than you were emitting before, and is also more economically expensive. So really questionable why you would even do that. So I think it's very important, and that's quite a striking example here, and has been a very, very important paper in terms of guiding that debate in the United States around the importance of carbon accounting for clean hydrogen. Again, for any type of industrial electrification, whether that be, you know, for direct steel, direct air capture, again, you're going to have similar results here. You need to think about proper carbon accounting. some of the methodologies used today are causing issues. Some of the claims around 100% renewables, some of the carbon accounting methodologies today, which, were set up a couple of decades ago in many cases, often made a lot of sense when they were set up. Now we're moving into an era where we need to be more granular and more transparent. The tools are emerging. So yeah, we really need to kind of avoid these types of criticism associated with today's carbon accounting and move towards more 24/7 or granular accounting. Okay, again, just to take one example of, in Europe, they've actually decided now to use 24/7 type rules, so hourly matching local electricity from new assets as the requirement for renewable hydrogen production in Europe. The United States is expected, it seems like might do something similar. They're announcing that next month. I'll skip through this one. It's just to highlight a point I've just made. That's the European regulation on green hydrogen. They are expecting a huge amount of import. So it's just interesting for any country that is seeking to produce renewable hydrogen for export into Europe. They'll have to do it this way. So they're going to have to set up their local procurement systems and energy tracking systems and granular certificate systems to prove hourly matching of renewable electricity to hydrogen production in order to import into Europe. And again, as I've mentioned, the Greenhouse Gas Protocol, on which science-based targets, CDP, any large corporate in the world, essentially 9 of 10 Fortune 500 companies are using this standard. Today, it's under review at the moment. It's going to be changed. And, we're certainly advocating for granular or hourly type accounting to become the norm globally for corporations. And I think it's probably prudent to prepare for something like that. So now I hope I've provided some background of why I think this is important. Now a couple of slides before we move to questions of a couple of slides of how we move to questions of how to set something like this up. I know some of the next speakers, Energy Track and Trace in the AIB, will dig into details on this also, but here's my own view. So, avoid coarse emissions tracking. If you're setting up a new system today or thinking about an update, definitely prepare for a world where, things are going to be more granular. Ensure there's time stamping on your certificates, etc. Unlike some of the systems that have been set up maybe a couple of decades ago in Europe, when it made sense to do coarse tracking. Now we're probably entering into an era with hydrogen, with the Greenhouse Gas Protocol, where you need to ensure you have a system that can enable the most advanced type of procurement. So that means having granular generation data is absolutely key. So make sure you have the metering in place to provide, granular hourly production data for all energy sources. Have standardized time-stamped granular certificates to do the tracking between the production and the consumption of electricity. And obviously have granular load data where possible also. Hourly matching is actually not really rocket science when we think about it. It's just making sure you have really clean and granular production data for electricity, consumption data for electricity, and then a certificate in the middle to make sure that electricity that has been produced is only being allocated or attributed to one consumer only and to one claim only to avoid double counting. That's essentially what a government, for example, needs to ensure is in place so that a hydrogen producer or a data center can go ahead and start to make hourly matching type claims and move towards more advanced types of procurement. So that's in a bit of a nutshell what really needs to be done. Energy Tag was founded in 2020 to actually help try to harmonize the slide I just presented above, basically, right? The more we can do this globally in a standardized and harmonized way, the easier it's going to be for large multinational companies, the easier it's going to be to set up, international markets for commodities like green hydrogen, to have the underlying infrastructure that is pretty much following the same principles wherever that's taking place in the world. Okay, so do check out our our website at the publication section, where we have our granular certificate scheme standard and use case guidelines, which will provide more information there. We're currently auditing 6 schemes, I think, at the moment, over 4 continents. So it's very exciting to see folks actually implementing this on the ground. Also, talk with your utilities. And try and encourage them to start to, offer hourly matching type PPAs like the ones I've listed here. I'll share the slides after. We also maintain a database of this on a spreadsheet at EnergyTag. In my view, quite clearly, this is the next generation of power purchase agreement, where in fact there's a contractual obligation to deliver X amount of hourly matching. So this column here, right? So, taking Google's deal of 500 megawatt PPA with AES, so that's a large utility in the United States, they've actually guaranteed that 90% of the hours in the year will be matched with clean electricity for 10-year contract period. So this is actually quite new. Normally, PPAs don't have these types of contractual guarantees embedded in them, but I fully believe going forward in the future they will. Consumers will want to know, well, how much of this energy is really clean that I'm getting, and how much on an hourly basis. And certainly a hydrogen producer will have to know that, because their whole business case will be based on it. If they have a PPA that's just 20% hourly matched with clean power, that's just not going to fly in Europe. It's not going to be enough clean energy on an hourly basis to actually make the economics of that hydrogen project work. So yeah, I really think this is the next generation of PPA. And of course, these have to be more multi-technology PPAs that are thinking about a portfolio of assets, not just wind or not just solar, but a combination of all of the above, including batteries, including lithium-ion, including geothermal, that really get us to much higher levels of hourly matching than we see from just one technology, because ultimately that's what we need. I know that Eurelectric, so the European utilities, are looking into a study at the moment on the hedging benefits of PPAs. And obviously there's a link here, okay? So anytime you sign a long-term contract where you're only getting 50% of the electricity you need, you're going to have to buy the other 50% from the power markets, for example, in Europe. And that leaves you with a lot of price exposure, basically. So these types of contracts, not only are they doing more for decarbonization, they're actually doing much more to manage price risk associated with your energy in the long run, which is valuable, particularly for consumers and large industrials very sensitive to electricity prices. So, I think these models are the types of models, at least for long-term contracts, that we really need to think about starting to enable. So hourly emissions tracking is happening. I know that in Taiwan you have a system that really is quite looking at 15-minute matching already. I know that Energy Track and Trace are coming up soon, so they're going to be talking about their system in Northern Europe. MRETs in the United States are offering hourly tracking, so it's already happening at different levels around the world. So it's and I'm sure hydrogen regulation in the US, for example, will greatly speed up the speed of the availability of granular certificates also. So these are just the EnergyTag demos on our website. I do present this slide, in fact, to many others, but I know you probably know quite a bit about this. But what's actually happening in Taiwan is very, very interesting, and I think really a model or elements of a model for anyone trying to set up a granular certificate system. Doing time matching from day one, I think is really important. Obviously, standardization and normalization of your systems with others around the world will be really important for the likes of whatever Google or Microsoft who have facilities all around the world and who'd like to basically buy the same type of instrument, do the same type of matching no matter where they are. This is an example of Google's 24/7 dashboards. They're certainly one of the leading companies in this space and publishing a lot of really great information and transparent information about how much hourly matching. So these are the figures here, basically. In Iowa, they're already done their job almost, but in other parts of the world, in Singapore, for example, they have only 4% of their electricity that's actually clean on an hourly basis. So, a long way to go there until 2030, where they want to have all of their data centers here at 100%. So there's definitely a challenge, but I think they're doing a good job and being quite transparent about where they are. A lot of small companies are doing this as well. So just to say, it's not just for large multinationals. There's a small t-shirt producer in the UK who's doing hourly matching because they want to be more transparent and for their own consumers. And a couple of other examples there in Turkey, in France as well, of smaller companies actually going towards granular tracking. So that's kind of it. I think, just kind of 3 rules, if we would. Emissions tracking for 24/7, has to be the end goal of anyone looking to decarbonize fully their electricity system. Implementing standardized granular certificate systems is a major key step in getting the accounting and traceability right, getting that framework there. And standardization is always really, really important to get these markets up and running in the same way around the world. So I hope that that's been useful. I wonder if there are any questions from anyone. Thank you.
Thanks for the invitation. And I think the order of the presentations is very good. We can now show what we are trying to build. We're building a solution that is to be 100% compliant with what EnergyTech is putting in place in terms of standards. So happy to be here and to explain a bit what exactly we are building. Let me try to set up things, share the screen. Okay, there we are. First of all, indeed, Elia Group. Who are we? So we are the transmission system operator in Belgium and in the eastern part of Germany. That's our main role. Besides that, we also own 50% of the interconnector cable between the UK and Belgium. And we have a number of so-called non-regulated activities in the domain of energy consultancy, engineering services, data, and offshore developments with our WindGrid subsidiary. What we see as a TSO in Europe is some key mega trends where, of course, the decarbonization is fully on its way. With that, there's also a lot of decentralization, new market players entering the market, and with all that, the need for a digital transformation. And Energy Track and Trace is one of the ways we do this. It's a fully digital product where we basically want to enable companies to achieve their 24/7 carbon-free energy pathway. Energy Track and Trace is not only Elia Group, so we are doing this with a number of partners, and the list is growing. It's a European partnership where we want to put in place the next generation energy tracking. So to give a bit of context, so if we look at a typical 24/7 CFE journey for companies, or where companies and their energy buyers will go through, I want to show this to highlight a bit where Energy Track and Trace is located and where we want to bring solutions. So, of course, it starts with awareness and education, companies knowing how to start the journey. But once they are there, it is about baselining and understanding a starting point. Where are we at this moment? How green are we today? Can we calculate our 24/7 scores in terms of greenness? That's the first step where Energy Track and Trace, using certificates, will offer a solution for companies to get insights into that baselining. Logically, then it's a good thing then to put in place a strategy. How will we as a company move to 24/7? how will we procure this? Which contracts do we need to put in place to get there? And then the last step here is where the core of our activity will be, is helping them in this accounting and reporting. So creating a trustworthy trace between the generation and the consumption, using trustworthy metering data, based on that creating certificates, which can then help them to make valid claims about the origin of their energy. That's the big aim. With Energy Track and Trace, so as I said, it's an international collaboration. It's us in Germany and Belgium, Elia Group, together with Estonia, Elering, the system operator in Estonia, Energinet, system operator in Denmark, and our last new entrant partner is Vertiser, is a daughter company of TenneT, the TSO in the Netherlands. And so together, we have developed a concept for granular certification. And the goal is that we put something in place that is decentralized. So in any location, in any country, a party could stand up and say, I want to do the issuance of these granular certificates. And we offer them the necessary building blocks to set up the service in their country and basically connect to a federated network throughout Europe. That's the idea. Yeah, I guess based on the previous presentation by Killian, I don't need to go too much into detail here, but why are energy certificates needed? If we look at the market today, there's the separate flow of the electricity itself through the different electricity market products, and then the separate flow of the renewable attributes markets, where you have a book and claim approach, issuing certificates at the production site and being cancelled at the consumption site. And there's a bit of the issue is that the current system of energy attribute certificates become limiting. They not provide 100% clarity to consumers due to this fact that they are not time-stamped, and also there's no geographical matching that happens. And that's where we wanted to jump in with our partnership and offer an extra layer of clarity on top of the existing attributes system. So it's really about end-to-end offering that base layer, that solid base layer, starting with the issuance. So the idea is we provide hourly or even at quarter hourly level certificates based on the metering data that we collect from production and consumption devices. So we issue these certificates. We then allow transactions to happen. So we support the different transactions where certificates get traded between companies, but also once they are then claimed together. So once we want to claim consumption against production, the idea is that we can take into account the physical aspects. For example, if you want to claim production in one country against consumption in another, but there is no physical electrical connection between them, this would not be possible to be matched. If there is a physical connection, the potential limiting of the flow of certificates is something we are considering, but there we are still very much in early stages and phase of testing. And then the last step of the flow is then the cancellation, and an important criteria is that time matching aspect, of course, that you can only match consumption and production that happened in the same time frame. So if we look from the energy system point of view, how this would work, typically you have your existing energy flow. Let's take here the case of a supplier, or either it's a large company that does in-house procurement. They've concluded a PPA, a green PPA, so that the consumption of their industrial site is covered by renewable production. How this would work is that we issue these granular certificates, time-stamped certificates, at the production site. We put them in our registry, and these can then be traded, can end up with the consumer, and the consumer can then claim it against their granular profile of consumption and get. It's very similar to what we saw on the Google slide in previous presentation. You get some type of clock where you see for each quarter hour how green were we exactly during the day. And that's the interesting thing that, of course, PPAs do a good thing, but to achieve 100% coverage of your consumption profile is nearly unachievable. So companies will need to look into wholesale markets and other markets to get the remainder of their renewable energy. And that's where this system with granular certificates and the fact that they can be traded freely will offer a lot of advantages. So if you look at the whole ecosystem, you have the users on top, the consumers, the companies who want to get to 24/7 carbon-free electricity, suppliers that offer contracts. If you look at that whole layered system, we are oriented really in the base layer. So again, these 3 steps: issuance, supporting all the transactions, doing the cancellations, is something we will support, and as such enable these suppliers and their consumers to reach these objectives. And of course, we expect to be part of a big ecosystem. It's not only these parties. We expect quite some service providers as well to pop up, and we already see some examples of that, like marketplaces where you can buy and sell granular certificates, doing portfolio management and matching for suppliers, auditing, reporting. So a whole bunch of new activities that will become possible. If we look at this pure base layer, we see 3 important capabilities that will happen and that we will enable with our product is, of course, the issuance. It requires a very solid onboarding and assessment of these devices and connection to trustworthy metering data, which has sufficient resolution, ideally 15-minute basis data. And then basically issue the certificates based on the information that comes in. Second big capability is we will enable wallets, and the wallets are the places where owners keep their certificates. They can be owned by any party, so it can be the owners of the asset themselves, energy suppliers, traders, etc. Anyone can create 1 or more wallets to keep certificates, and then you can start transferring basically certificates between wallets based on transactions that you make. And the third one is the solid backend of the whole solution is the registry itself. This is the single source of truth for these certificates. The certificates need, of course, to be immutable. Once created, it is impossible to change them. We foresee public verification possibilities so that a service provider can do verifications. Of course, the data itself will be encrypted or hidden to protect privacy. And the whole registry is auditable and tamper evident. It's supported by a 2-layer blockchain, so that it can at any time be verified if what is in the registry is still 100% correct and unchanged. So 3 important capabilities. Now, if you look at the landscape, different countries in Europe, the issuance of granular certificates is something that is quite country specific. The way you will get to the metering data depends on country level organization, on who is the party that collects the metering data. It differs from country to country. However, the whole wallet concept, the registry concept, is something that is to be identical in every country. It's also a core element. We want to create a federated network where registries in different countries can communicate with one another as part of this federated network. So we need all the registries and the wallets in each country to be identical, using the same interface, being able to talk to one another. So that's when, with our partners, we concluded that wallets and registry should be a joint development, and we decided also to make it an open source collaborative effort. So basically all the code of these two capabilities is available open source, and in this way we want to enable the ecosystem to flourish. So to allow anyone in their country to step up and say, I will now take this wallet and registry code and spin up my instance, and by using that exact code, I'm sure that it will work together with the other countries. That's why this Project Origin project was set up. This is the open source part of our initiative. And to dive a bit into that Project Origin aspect, that open source aspect, there's quite a number of challenges we needed to tackle. First of all, the goal was we need a trustworthy data system where we can do this verification, certification. So every step needs to be very clear and solid. Secondly, blockchain was one of the possible ways to support this technically. But if you look at the number of data points that will need to be processed, we saw that there's quite some limitations in scalability. And so that's why in the project now a layer 2 data handling is put in place. Basically, a whole bulk of transactions is translated into one encrypted hash, which is then put on the blockchain, so reducing the whole scalability issues and the costs of operations. Secure transfer and settlement needs to be enabled, and again, this privacy, the sensitive data need to be protected. That was also another requirement, and it needs to be open so that we can still allow this independent third-party auditability of the whole solution and of the contents without breaching GDPR, so the privacy of the data. And so the approach was, okay, we will develop the registry with external partners. It was mainly Energinet who took the lead in that, setting up the Project Origin initiative, and we from Elia Group are participating. The open source approach is meant to let the ecosystem flourish, so let other system operators and market service providers co-implement to really bootstrap a full market of granular certificates. And so it's meant to help us scale throughout Europe, implement a federated network where we have these different independent registries that by design are able to communicate with one another. That's about Project Origin. An aspect which we, of course, should not forget is Energy Track and Trace is set up as a complementary system on top of the existing renewable energy certificate system. So we need this coordination between the two to avoid double counting. And so being compliant with the European Guarantees of Origin scheme is of crucial importance to end up with a trustworthy solution. We have written a paper on that, published. We also provide a link to that to show how we see this coordination happening. And we're now in the process of testing that in Germany. Concretely, so there's a first product available at this moment in Belgium and Germany. Soon, by end of this year, beginning of next year, we will have one in Denmark. Solution that supports pilot projects, and in the meantime, we are making the solution even more solid and work towards a real full release of the product to all interested parties. So there's a user interface aspect to it where users can easily onboard their devices and get some insights based on the wallet, based on the certificates that are being issued. But there's also a more technical API part, basically to support service providers that want to build solutions on top of this certification system. As I mentioned, we are this year is a lot about testing, making the solution more mature. We have APIs exposed today to a number of pilot users that want to contribute and test to the solution, and working on new features so that in 2024 we can go live as a voluntary product. So it means as an extra layer on top of guarantees of origin. So the idea is, of course, we have this integration with guarantees of origin, but will at that point also support cross-border flows of certificates. Importantly, also have storage implemented, because storage in terms of granular certification is a specific subject that needs attention. And so it aligns a bit also with external events we see happening. So we clearly see in Europe a shift towards more granular, a need for granular certification of the origin of energy. The revision of the greenhouse gas protocol that Gillian also mentioned, and on the longer term, the obligation for hydrogen, if you want to consider it renewable, that you also need this time matching to be done. So very exciting things are happening there in our companies. We are coming closer to full release, and we're really convinced that the solution we will bring will help companies forward towards that 24/7 energy. I have put 2 links here on the last slide. The left one is our energy track and trace website, where basically you can find more information about the publications we made, about the concepts we have defined and put in place. On the right side, we have the link to the open source repository of Project Origin, where we have these registry and wallet capabilities being developed. This is fully open, and also any company who wants to participate and contribute is very welcome. How to do this, it is all described in the repository. Thank you for your attention, and looking forward to some questions.
It's a great honor to be here with you on my behalf as well. I am some background on me. I've been working on energy origin tracking systems for 21 years now, of which 17 years I've been working for a regulator as an issuing body for guarantees of origin here in Belgium, Flanders, and a disclosure supervisory authority. A few years ago, I set up my own company, and I mainly spend a lot of time with the AIB, the Association of Issuing Bodies, on strategy coordination for the European issuing bodies of guarantees of origin. I also spend some of my time with Energy Tag to update the Energy Tag and fine-tune the Energy Tag standard and coordinate the audits of granular certificate issuers. And I've had also the pleasure to work with the Taiwanese Institute of Economic Research on identifying some differences between the Taiwanese and the European system, but also to identify a lot of similarities and a lot of strengths of that. Today, I've been asked to talk about a reliable tracking of renewable hydrogen that supports the energy transition. So let's talk about what that means. Reliable tracking of hydrogen or of any energy stream that has an impact, that supports the energy transition. That consists of 2 main pillars, being reliable and impactful. And on reliable, I think we definitely have many years of experience, and it's good to zoom into what can we use of the years of experience of existing tracking systems, and how can we make them more impactful, because that's really what we observe these days, that tracking systems are asked to be much more impactful, and where they lack, so they seem somehow to be criticized. So let's first zoom into that reliable aspect. It means definitely in the first place, if you use a proof of the origin, then it has to be unique proof. And let's look at what can energy attribute certificates do to be a unique proof. You can document the attributes of energy production, you can convey them to a consumer in a reliable way, and also it's important to validate them at consumption to make sure that that proof is not used again somewhere else. It seems self-evident, but it's a lot of work to make all that happen. And the world's biggest energy attribute systems, they have these as core building blocks. It requires them to have attention to prevent fraudulent qualification, to prevent double qualification or double issuing, duplication during transfer, preventing double cancellation, and what's the hardest part is preventing double claims. So looking at the systems, what can we learn from the electricity tracking system, and can we convey something from that to the hydrogen tracking systems? Electricity energy attribute systems have always worked in a book and claim context, and it's possible to operate hydrogen tracking systems in a similar way, but we may have to add things on top of that. So how does that look? A book and claim system for tracking is you produce an energy carrier. So here with electricity, with wind electricity, you produce hydrogen and you convey it into the physical hydrogen market where the hydrogen is traded. The molecules don't have the energy source inherently in them, and at a certain point the consumer consumes it. The attributes, the renewable character of it is documented in an energy attribute certificate system where certificates based on measurements and verifications of the producer are issued in the registry of an EAC issuer on the account of a producer who can transfer it to a trader account. The market of AX can play, give additional value to the producer, and in the end, the AX has to be cancelled, has to be redeemed, retired, make sure that it's invalidated and the a consumer is informed of renewable disclosure of that energy origin. This system enables consumer choice. The book and claim aspect promotes market efficiency and simplicity, protects liquidity and supports the internal market, but it is essential for a book and claim system that double counting is prevented in every single step. So that last step I said is usually the hardest one, preventing double claims, because even if you organize your system perfectly, at the end, if somebody claims the same instrument in multiple ways or the same energy attribute in multiple ways, you still have all that work done for nothing. So what can we learn from Europe here? If you document here as a symbol an energy stream here, electricity, that goes into a physical market, and consumers want to be documented at the end of the origin of that energy. And that can be done with what we call in Europe the guarantee of origin system, in Taiwan the Taiwanese TREG system. And this documentation of the end consumer or information of the end consumer we call electricity or gas disclosure. And in Europe, we organize this to have an obligation to suppliers to disclose the origin of their electricity on their invoices, and we have a draft obligation for gases on this as well. And this obligation is organized in an internal market directive that makes sure that suppliers have to disclose this origin. That makes it also like if they don't disclose renewable origin, they have to disclose fossil or nuclear origin, and that in itself leads to less confusion on potential other green images that then are not backed by the AX system. That system is also in draft for the gas market and gas suppliers. And the guarantee of origin system is in Europe regulated in a dedicated separate directive. But for gases, we have an additional complexity. The disclosure aspect is in one instrument, the guarantees of origin, but there is a target accounting aspect related to it that requires more things than just a renewable origin. It requires documentation of sustainability, verification of whether criteria are met related to greenhouse gas reduction. And that comes with an additional challenge to prevent cross-purpose double counting. And what do we mean with that? We come to that in a second. Let's talk, before going there, on some basic principles for reliable disclosure. So disclosure of the origin should be mandatory for energy suppliers. Then you have at least the basis of transparency where you can say, okay, this is or is not true, and you know what means you can use to check such claims, or what means are used. Reliable energy attribute certificates are the preferential way to explicitly prove the renewable origin of energy, or any other attributes of the origin of energy. But if you don't use the energy attribute certificates, then it's also important to explicitly include the alternative mechanisms so that you have an overall overview of what type of instruments are used, and you can check on prevention of double counting. And those are necessary to have explicitly in view, because the residual mix is then calculated and used. Residual mix is basically the leftover mix of attributes that are not documented to energy attribute systems. It is mandatory to use it for disclosure of sold or consumed energy, for which no energy attribute systems or energy attribute certificates are cancelled. And what we also proposed in the FASTCO project, based on the REDIS project recommendations, is that there has to be appointed a competent body for supervision and verification of disclosure to make sure that there happen no errors or no fraud in that claim. As I said, there is coming in Europe also a mandatory gas disclosure legislation that includes renewable and low carbon hydrogen. In Europe, we have a framework for harmonizing these guarantees of origin. As Gillian rightfully pointed out, standardization is essential. Gradually, standardization is further evolving, and also legislation is further directing what should be included in such standards. But the framework we have in Europe for harmonizing guarantees of origin is, first of all, a one-pager in the European Energy Directive, the Renewable Energy Directive, that says that majority of the details have to be elaborated in a CEN standard, and CEN EN 16325 standard on guarantees of origin. And that standard will set out the reliable condition, the reliability condition, how to operate guarantees of origin in a harmonized, reliable way. To make it really efficient in Europe, because we have a mandatory cross-border transfer within Europe, the European Energy Certificate System, as maintained by the AIB, is an essential aspect to really prevent too high overhead costs while ensuring that reliability. It's good that the issuing bodies are gathered inside AIB to together make agreements on how to organize for all this. Then talking about the different energy carriers. So if you want to disclose the origin of a gas that's injected into the gas grid, you also need a guarantee of origin system, whether renewable or fossil. You can only know that from the molecules if you have a guarantee of origin or a similar document combined with it. If you use that gas to further convert it into another energy carrier like hydrogen, then you need to have a mechanism that enables to convert or to document the conversion of that gas to the hydrogen. The same with electricity that is converted into hydrogen. You need a mechanism that documents the conversion of electricity into hydrogen. And so in short, we say energy carrier conversion demands GEO conversion issuance or EAC conversion issuance. The input energy carrier in a hydrogen device needs to be accompanied by cancelled guarantees of origin in line with the measured input energy into such device, and GEOs can then be issued for the hydrogen that is released from that conversion device, and then they can be released onto the market. And here the attributes of input GEOs, some of them can be conveyed to the output, or it is under discussion how many of them will be mandatorily conveyed, but as a minimum, that will be the energy source. So in this example on the screen, you have in the upper scenario hydrogen from agricultural biogas or biomass, and in the lower scenario, you have hydrogen from wind energy, because it's documented through a cancellation chain of guarantees of origin. That topic of inheritance of attributes after conversion then deserves careful attention. We had a project, we call it the Regatrace project, where we published 2 dedicated reports to that topic on how to organize for it and how to organize for more process-related challenges on conversion issuance in general. We measure the input, we measure the output of a conversion device. We can cancel GEOs and issue new GEOs for the output. And it comes with processes of verification and information conveyance. Making sure that these processes are well organized is quite essential, because if they are too expensive, it's not scalable, or scalability will be too expensive. And then the overhead cost might undermine the rollout of a market for clean hydrogen or any clean energy source. The Regatrace project also identified a few more challenges on how to actually make that happen in practice, and how to overcome them, or how to approach each of those in a reliable way. Maybe today it's a bit far going to go in detail on those, so let's look at it like this. Then let's talk impact. So we said in the beginning we have two main pillars. One main pillar is reliability, and second pillar is impact. So we talk now mainly about reliably conveying the energy source from production to consumption. But how can it then be impactful? And we could learn quite something from what happened in Europe. And if you're still at the design table, you may have some considerations on what is a good takeaway from that. So actually, it's important to look at the purpose of energy tracking. And what Europe has done is segregating it into at least three purposes. The purpose of what we talked about today so far was mainly disclosure, informing a consumer of the origin of its consumed energy. There are other purposes, like governments that want to achieve targets, and that's just accounting towards that target, but often it comes with a financial stimulus. Financial support in itself is not always related to disclosure or target accounting. There are simply subsidies in themselves. And so Europe has organized this as in separate incentives. And you could consider, well, there have always been discussions, should we combine multiple of those into a single mechanism or not? But so far, the instruments at the EU legislative level are separated from each other. So disclosure is a consumption incentive to consumers to drive the energy transition. Europe has several initiatives for that, of which the Guarantee of Origin instrument, the disclosure legislation, and now also the Corporate Sustainability Reporting Directive with related ESRS standards. Then target accounting is in Europe a production target, but it bases itself on overall consumption figures. And actually, even for the renewable transport target accounting, it comes down to really at a specific consumption point, accounting for a target of renewable content in transport fuel. And there it comes closer to disclosure, although it's not explicitly regulated like that, which gives rise to confusion. And then production incentives are in many separate pieces of legislation at local level and at EU-wide level. But after 20 years of observing this segregation of purposes, I have to say that spreading different tracking purposes over different instruments, it does dilute the impact of each of them, and it gives some rise to confusion here and there, which makes it hard for new policy builders to have a clear understanding of the status quo before they start building new policy. So let's talk about this renewable transport fuel targets requirement, because that's also what Killian already referred to in the as the RFNBO Delegated Act, Renewable Fuels of Non-Biological Origin, or RNFBOs. In Europe, in the Renewable Energy Directive and in the upcoming update of it, there is a clear push for an increased share of renewable energy in transport that is now also extended with, it could be expressed in greenhouse gas intensity reduction increase. And that target comes with criteria that are well set out and they relate to sustainability and greenhouse gas emission saving. This meeting of these criteria needs to be certified by certification bodies who operate under national or voluntary schemes that are recognized by the Commission, and they must be tracked through mass balancing. And that came with a lot of questions like, what does mass balancing mean, and has been clarified by the Commission in also in implementing regulation. For gases, it means like if it's injected into a single logistical facility like the European Interconnected Gas Grid, it is very similar to book and claim, because there that single logistical facility is considered one step in a mass balancing chain. And an additional layer of complexity now is that liquid and gaseous renewable transport fuels have to be tracked in the Union database. This originates from a need to also preventable counting in mass balancing systems that don't have guarantees of origin with them. They don't have a unique instrument that accompanies them throughout the whole supply chain in a regulated market like the electricity and gas market. So for liquid transport fuels, this has been a very meaningful idea, but with gaseous transport fuels and electric transport fuels, it somehow has a coincidence and overlap with the guarantee of origin system, which comes with operational challenges. This voluntary schemes framework in Europe, it comes with a whole sector knowledge need on how these how voluntary schemes are coming into being, how they come to be recognized by the European Commission, which verification rules they set up, and yes, how it also takes a time for every voluntary scheme to get that recognition, and also when regulation updates to comply with that regulation update. But the European Commission is transparent on the status of this. They have a website that explains which schemes have that recognition by the Commission today. And also for hydrogen, there's one specific, there are several of the existing ones that are extending to hydrogen. There's also one that made a specific application for mass balancing of hydrogen, which is a certified voluntary scheme. So now back to all this topic of 24/7 carbon-free energy, because here it's actually where you see somehow that it's that the book and claim systems and mass balancing systems come very much closer together, also on the electrical sector. These renewable fuels of non-biological origin, as Kilian rightfully pointed out, there is a risk that they would be very unsustainable, and it's important to call them renewable based on criteria that actually ensure that they have a positive impact on the energy transition. These criteria have now been clarified in delegated acts, and it's a bit a combination of various aspects. It has to do with the location of the production device, the area where the production device is located, but a very important aspect of it is temporal correlation of production with consumption, and which is identified as within the calendar month until 31st of December 2029. But after 2030, that should be within the hour. So hourly correlation of electricity production with compared to the hydrogen with which that electricity is produced. And geographical correlation is also an important criterion, and also Michael talked about how Energy Track and Trace is really taking that into its project as a core steering aspect. And this delegated act defines what it means. It means that renewable energy production should be in the same bidding zone, market zone on the grids, that means, as hydrogen production, or interconnected bidding zone with a higher price. So it will be quite an element for the voluntary schemes and the guarantee of origin systems to make sure that in this verification of all these requirements, efficiency is gained in the system design. Also because there are more criteria, they relate to additionality. The hydrogen should come from electricity that is in a production device that's less than 3 years old and hasn't received financial support. So moving towards what can we draw away from all these developments in Europe, from a bit scattered landscape of different policies that all come with great intentions towards having a real impact on the energy transition, and they can have an impact on the energy transition if we don't get too confused, and if we, at the implementation side, also manage to maintain clarity here. And we see that a lot of times confusion happens. So don't confuse the asset with the way the asset is transported. A lot of debates go on book and claim versus mass balance. Tracking purposes are mixed. So it's important to clarify, what are we tracking? Are we tracking attributes, or whether certain criteria are met? Energy source and location and production device age, for example, they are very much objective attributes, but the criteria are met. It's coming with a lot more verification aspects and often calculations, more checking of more documentation. Then the purpose of the tracking, it's important to have clarity on that. In Europe, it has been okay to segregate the purposes. Several countries now go into a direction of combining multiple purposes in one tracking instrument. Some find that a bit more complex for the overall system management, but in the end, you save resources, and you're more efficient in the overall impact and more impactful with what you actually establish with your tracking system. The tracking mechanism, so you have book and claim systems, you have things you call mass balance, which is actually documenting at each step of the supply chain. You have bundled sales of certificate with energy, which comes close to mixing both. You have temporal and geographical correlation in book and claim systems. So that's the area, the overlap area between these tracking systems gets bigger, and that's also interesting to see, because the areas where each of the systems has been criticized before are more acknowledged and are more brought together into an integrated way of looking at reliable tracking. And then it's super important to include this consumption verification mechanism to make sure that claims don't happen just in a wild jungle, and that double counting doesn't occur at the claiming side, which in Europe is organized by disclosure supervision on energy suppliers and by mass balancing through voluntary schemes that confirm the consumption category. Just to clarify that there are many terms that can be easily confused. So summarizing, how to ensure impact while preventing double counting of renewable energy. In the first place, you have to ensure that reliability. If reliability of the instrument isn't in place, then everything is undermined. The energy attribute certificate that you use has to be a single proof. Use the same instrument everywhere makes it easier for consumers and stakeholders everywhere in the world to understand it. So harmonization and standardization is quite important there. Also, referring to the Greenhouse Gas Protocol, which is widely adopted in corporate emission accounting, it's strongly recommended to make sure that where legislation foresees market-based emission accounting instruments or energy source accounting instruments, that it would be recommended to forbid location-based accounting that doesn't keep into account the market-based accounting. If a link is made between the two, that concern can be mitigated. The pure location-based accounting is undermining market-based accounting where legislation would organize such. And enforce the use of the residual mix for claims that are not backed by energy attribute certificate systems. That's also important to make sure that the EAC is the unique proof. That is reliability. Then if you feel at the design table that the impact of the EAC instrument in itself is not enough yet, then it's worth improving that instrument. Increase the information you record on the EAC. Check whether you can include multiple purposes into a single instrument, and also enable to confirm by inspectors, by verification organizations, to enable to confirm additional criteria. Deliverability has definitely been one that enhances trust. The grid-connected consumption and production, for example. Temporal correlation has been set out very extensively by Kilian and Michael, why it really matters, and additionality is also has never gone off the table of concern at the consumer side. As I said, I had a good chance to look deeper into the T-REX system in an interesting study, and I really can say that the T-REX system provides a very strong building block for an impactful instrument from electricity to hydrogen for hydrogen tracking. Thank you very much for your attention. Let me know if you have any questions.